And at the bottom of page 301, we have this diagram, and in this diagram, I would like you to take out your highlighter and highlight the factored form of the equation. And this is the factored form right here. I believe it's on your formula sheet as well. Okay? And then if we turn the page to page 302, if you know, and maybe I'll use the example that you had just above. The one with the 3x squared. Let's write it out. You had 3x squared minus 9x minus 30. And because you can factor this, you can factor out the 3. And then this factors nicely to be x minus 5, x plus 2. You would know the a value tells you that it opens up. But if you write it in factored form, you can find your x-intercepts by plugging in 0 for y, and then you have a chapter 3 question. If y is 0 and it's already factored, you can use the zero product property and saying if you have things that are multiplied together and the answer is 0, one of the things you're multiplying together has to be 0. So you check. Could it be the 3? No. 3 is never 0. Could it be x minus 5? Yes, it could be x equals 5. Could it be this one? Yes, it could when x is minus 2. So you would know your 2 x-intercepts. And because you know your 2 x-intercepts, and you know that it opens up, it looks like this, you would also know the axis of symmetry has to be right between -2 and 5. So we could find this by taking -5 and adding 2 and taking the average. And you could find that the axis of symmetry is x equals -3/2, which would also tell you that you know the x-coordinate of your vertex. You could find the y-coordinate of your vertex by just taking that number and plugging it into your equation, either into the general form or into the factored form. You could choose. And then you'd find your y-coordinate. So they have this on the top of the next page. You can highlight this. Your axis of symmetry is always the average of your x-intercepts. That's right here. You can highlight that on your graph on the previous page as well. So we can always find that value of our axis of symmetry. So let's go to example 1. Identify the intercepts, the equation of the axis of symmetry, and the coordinates of the vertex. This question is asking us to find 4 things. It's asking us to find the y-intercept, the x-intercepts, the axis of symmetry, and the vertex. And this is where the chart that we drew at the very beginning is super helpful. Okay? You notice they gave us the general form of the equation. So according to this chart, we're starting in the blue. We need to find intercepts, vertex, axis of symmetry. So starting in the blue, of those 4 things, what's the easiest one to find first? The y-intercept, because that actually is highlighted in yellow. It's super easy from the general form. So I'm going to do that first. If I want to find my y-intercept, I just plug in 0 for x. You see that you get 0 plus 0 plus 10. 0, 10 is the easiest. Now I have to find the x-intercept, axis of symmetry, and vertex. Now according to my diagram, and you have choice in what order you want to go about doing this. So I need my vertex, I need my axis of symmetry, and I need my x-intercept, okay? The vertex and axis of symmetry, I said normally it's fastest through the standard form, okay? But I have to use the factored form to find my x-intercepts. And then I could find my axis of symmetry if I have this. I might choose this pathway for my vertex anyways. So we'll look at both in this question, and you can decide what you would like to do. But you do have to find the factored form because that's the only way to get your x-intercept. So I'm going to actually start with that. So we'll go back to our example. We're going to change it to factored form. So in other words, we have to factor out the negative 2.5. That would leave me with x squared. Does it make sense when you factor a negative out of a negative, you will get a positive? How many 2.5s are there in 7.5? 3 of them. So I will get plus 3x. And if I factor a negative out of a positive, I will get a negative. How many 2.5s are there in 10? 4. Negative 2.5. And then does this factor nice? It does. X and x. Can't be 2 and 2. It's going to have to be 4 and 1. My 4 has to be positive. My 1 has to be negative. Multiply it out in your head to double check. And then if we set y equal to 0, then we can use the zero product property. And find out that one x-intercept is at negative 4, 0, and the other x-intercept is at 1, 0. Because I started in the factored form, right? Can you see that right now we are here? It's not far to go there to get the axis of symmetry. That seems a lot quicker than going this way at this moment to get the axis of symmetry. So I'm going to keep with the factored form. I'm going to find my axis of symmetry. I'll do it in red because we usually draw it on a graph in red. My axis of symmetry is going to be just the average of my intercepts. You can keep the blue one if you want. Okay, and then it's in here. There, and you press donut. So we can write down our axis of symmetry at negative 3/2. And if you have your axis of symmetry, you already know the x-coordinate of your vertex. So you could choose either, I'll put a 1 here, you could choose either to plug it into the original equation and find your y-coordinate, or you could choose to plug it into your factored form and get your y-coordinate. So if I chose 1, so if I'm going to find the y-coordinate of my vertex, then I would have negative, and I'm going to change everything to fractions to make our math easier. (7.5) is 15/2. Order of operations, you're going to square first, so I still have negative 5/2. Squaring 3/2 will be 9/4. Multiply those will give me plus 45/4 plus 10. And then multiplying these will give me negative 45/8. I'm going to get a common denominator for each of these. And I find out that my y-coordinate is 125/8. I could have also Let's see if the factored form is a little bit easier with our mental math. I'd still have negative 5 over 2 out in front. Let's plug in negative 3 over 2 plus 4, and negative 3 over 2 minus 1. Order of operations, I would do my brackets first. I'd get a common denominator. So negative 3 over 2 plus 8 over 2 is positive 5 over 2. And negative 3 over 2 minus 2 over 2 is negative 5 over 2. Actually, the mental math looks a little bit easier here. This will be 5 times 5 times 5, 125, positive because of the two negatives, and 2 times 2 times 2 is 8. Maybe a little bit easier in the factored form, because you didn't have the squaring part and less common denominator stuff. Okay? Now, if we go back to our diagram, the question asked for vertex and axis of symmetry. And normally I would say that's almost always better with standard form. But because we needed our x-intercepts, we had to go through factored form. And since we were at the x-intercepts, we're like, ooh, it's only one step away from axis of symmetry. And then once I got the axis of symmetry, I'm like, ooh, it was only one step away from the vertex. So maybe that was faster in this situation, but you could have also completed the square. And you're going to find, we're going to do that in example 2, that sometimes that is quicker and easier. Okay, questions for practice for number 1. They are 3, 4, and 5.